Okay, quick review of quadratic functions. Quadratic function, we're going to use x of t as our function. It's going to equal at squared plus bt plus c. Now, you really need to understand quadratic functions, okay, to do anything beyond the level of algebra. And they're revisited in pre-calculus. To deal with this quadratic function, the first thing we want to do is put it in a more accessible form. Now, it doesn't seem more accessible, but it is. We complete the square. Again, a process that you learn in Algebra 2, apply in pre-calculus, apply again in calculus, apply again in vector calculus, and other places in between. We complete the square on this, and I'm not going to show you how to do that. You should do a web search and make sure you do understand how to complete the square, because if you're in a university physics course, you're going to have to do that in your math courses. You've already done it in many math courses. So we complete the square. We get the form x of t equals a times the quantity t plus b over 2a squared, plus, and I designate this by x of negative b over 2a. The quantity that you get when you plug in negative b over 2a, which arises naturally in the completing the square, into this function. And if you plug this into the function, you get negative b squared over 4a plus c. Now we then understand the graph of x of t as a graph that you get when you start with the t squared function, vertically shift it by factor a to get the at squared function, and then shift that graph negative b over 2a units in the x direction, and then shift that graph x of negative b over 2a, or negative b squared over 4a plus c units in the y direction. Now, if we can't look at this graph and see that shifting, we have a problem in dealing with the graph. And of course, a lot of people have that problem because so often we just bypass the whole question of what the graph means and how it's constructed and just punch it into a graphing calculator, which should be banned until the junior year of college. Okay, now, or at least the junior year of an engineering program. You need to look up transformations. You need to understand these shifts. Now, this vertical shift, the shift in the y direction, and I say the x direction, that should be the t direction. And since we're graphing x versus t, this would be the x direction. But this means you shift this in the horizontal direction. And we shift this in the vertical direction. Okay? Clearly, adding this to whatever this is shifts the graph in the vertical direction for reasons you should be very familiar with. Replacing t with t plus b over 2a shifts you in the negative b over 2a direction, by negative b over 2a units, in other words. Again, you need to understand why that is. Okay, so again, you might have to do some review. You might have to go back to your pre-calculus, get a pre-calculus text, look up transformations of graphs. Very important topic in pre-calculus, and you really need to understand it to deal with functions. Okay, in any case, now x of t equals 0, what? If and only if, well, if and only if this thing equals 0. Now this thing here is, and we replace this by the negative b squared over 4a plus c. So we see that x of t has to be 0 if and only if this is equal to 0. This is easily solved. We subtract c, add b squared over 2a to both sides, and then we divide both sides by a, and we get b squared over 4a squared minus c over a. And that's going to be equal to t plus b over 2a quantity squared, so that t plus b over 2a will be plus or minus the square root of this, which means that t is negative b over 2a plus or minus this square root, which simplifies by simple algebra 2 to the standard form of the solution of a quadratic, which is something you should have locked in many years ago. and never forgotten, but don't forget it from this point forward if you did forget it. Okay, and this gives us a picture of our graph. We start with the y equals x squared graph. Let's say that's the purple graph. We vertically stretch it by factor a to get this yellow graph. Then we translate it in the t direction, in the horizontal direction, to get this green dotted line graph. And then we translate that in the vertical direction to get the white graph, which is the graph of our function. We really need to understand that process. It needs to be part of our mathematical understanding. The result tells us that the axis of symmetry of this quadratic function that we started with is at negative b over 2a. That's a rule that you can take home with you, but you should understand where it comes from in case you forget it. Shouldn't always be relying on things you look up on the web. And then you plug that value of t into the x of t function, and you get your negative b squared over 4a plus c, which is, of course, the x value, x being now on the vertical axis, t on the horizontal, so that the coordinates of your vertex are these. Now, you need to understand that about quadratic functions in order to have a really good command of the mathematics, and your prerequisite courses should have built that understanding, but probably didn't.